In December 2025, a team at the University of Arizona pointed the most powerful infrared telescope ever built at a tiny patch of sky, no wider than 1/10 of the full moon. They found a galaxy. It looked normal, small, quiet, young, only 800 million years after the Big Bang. They cataloged it and moved on. Then, someone switched the instrument from near-infrared to mid-infrared, and Virgil changed its face. Behind a massive, impenetrable wall of cosmic dust, something impossibly massive was feeding. A supermassive black hole that mathematically should not exist. Not there, not then, and absolutely not that large. Welcome to the Heriton INC archives. This is 3I Atlas. Tonight's investigation concerns a single object in the Hubble Extreme Deep Field, a region of space photographed so many times it was considered fully mapped, fully understood, every galaxy cataloged, every anomaly explained. The JWST observed that exact same region for over 3 years, and in the data, buried under layers of cosmic dust and routine classification, it found something the Hubble Space Telescope was physically incapable of seeing. The official story is straightforward: safe. Virgil is a compact, high-redshift galaxy hosting a dust-obscured active galactic nucleus, an overmassive black hole. An interesting data point for astrophysics journals. Nothing to worry about. The raw telemetry tells a different story. A story of a cosmic object that wears a disguise, that hides in plain sight, and that completely shatters the single most important scaling relationship in modern cosmology. Let us begin with what the institutions want you to understand. For decades, the standard model of galaxy formation rested on a clean, elegant assumption. Galaxies form first. Stars ignite, gas coalesces, and slowly, over hundreds of millions of years, matter funnels toward the center, feeding a growing black hole. The galaxy and its central black hole develop in lockstep. This is called the co-evolution model. It is one of the most foundational principles in extragalactic astrophysics. It is printed in every textbook, cited in thousands of peer-reviewed papers, treated as settled science. Under this model, there is a direct, predictable mathematical relationship between the mass of a galaxy and the mass of the black hole at its center. It is known as the MBH to M stellar mass relation. For every unit of stellar mass a galaxy accumulates, its black hole grows by a proportional amount. In the local universe, the cosmos as we see it today, this ratio holds with terrifying consistency. The black hole typically accounts for roughly 0.1% of its host galaxy's total stellar mass. It is a ratio so reliable that astronomers use it as a diagnostic tool. If you know the galaxy's mass, you can estimate the black hole. If you know the black hole, you can estimate the galaxy. This is the framework that every major space agency operates within. NASA, the ESA, the entire JWST science pipeline. Now, let's look at Virgil. Virgil sits at a redshift of approximately 6.6. That places it roughly 800 million years after the Big Bang. Deep inside the epoch of reionization, the era when the first stars and galaxies were just beginning to switch on the lights of the universe. At that extreme distance, JWST is essentially looking back in time, observing Virgil as it existed over 13 billion years ago. When the team first examined Virgil using the near-infrared camera, NIRCam, it looked entirely ordinary. A small, compact, young star-forming galaxy, nothing remarkable. It produced a standard Lyman alpha emission signature. It behaved exactly as the textbook said a young galaxy should behave at that epoch. If you stopped there, Virgil would have been filed and forgotten. One more faint dot among thousands. But the team didn't stop there. They pointed JWST's mid-infrared instrument, known as MIRI, directly at Virgil. MIRI is different. It sees deeper into the infrared spectrum. It penetrates the dust. It sees what other instruments cannot. And what MIRI revealed was not a quiet, young galaxy. Underneath that veil of cosmic dust, Virgil was hiding a supermassive black hole, accreting matter at an extraordinary rate, releasing immense quantities of energy that were completely invisible in optical and near-infrared wavelengths. The dust blocked everything. It was, in the exact words of the lead researchers, a cosmic disguise. But the disguise wasn't the problem. The mass was the problem. The black hole inside Virgil is far more massive than any mathematical model permits for a galaxy of that size at that point in time. It doesn't just slightly deviate from the mass relation, it demolishes it. Virgil's black hole sits in the category astrophysicists call overmassive, a clinical, sanitized term for something that physically should not be where it is. In the local universe, a galaxy this small would host a black hole, perhaps a few 100,000 times the mass of our sun. Virgil's black hole appears to be orders of magnitude larger. It is, proportionally, far too heavy for the body it inhabits. Think about that for a moment. The coevolution model says the galaxy builds first, and the black hole follows. But in Virgil, the black hole appears to have grown first, and grown fast, while the galaxy around it barely developed at all. This is not a minor footnote. This is a direct violation of a foundational law of physics, and it gets worse. Virgil belongs to a mysterious class of objects that JWST has been finding across the early universe. They are officially classified as little red dots. Since JWST began operations, astronomers have cataloged over 300 of them. They are compact, extremely red, and they appeared in massive numbers around 600 million years after the Big Bang. Then, roughly a billion years later, they almost entirely vanished. No one knows what they became. Nothing can leave the universe. Their descendants must exist somewhere today, but we have not identified them. Virgil is the reddest little red dot ever discovered, the most extreme member of an already unexplained population. And here is the critical detail that the mainstream narrative desperately glosses over. Most space surveys rely primarily on near-infrared data. Mid-infrared observations take significantly more telescope time. They are expensive. They are rare. That means astronomers may be systematically missing a massive hidden population of dust-obscured supermassive black holes scattered across the early universe. The implications of this are staggering. If Virgil is not unique, if there are hundreds or thousands of similar objects buried behind dust, then the entire picture of how the early universe evolved is a lie. The energy output from these hidden black holes could have contributed to reionization itself, the fundamental phase transition that lit up the cosmos. One researcher on the team put it simply: JWST has shown that our ideas about how supermassive black holes formed were, and this is a direct assessment from a lead scientist, fundamentally flawed. The textbook is wrong. The coevolution model, in its current form, does not survive contact with Virgil. So, the standard physics fails, the scaling law breaks, the timeline collapses. The only question left is, what are we actually looking at? Let us explore this as a thought experiment, a hypothesis, an exercise in following the data to its darkest logical extreme. Hypothesis 1. Heavy seeding. If black holes in the early universe did not grow slowly from the remnants of dead stars, then they must have started enormous. Some theoretical physicists have proposed that in the first moments after the Big Bang, conditions may have allowed for the direct collapse of massive gas clouds into black holes weighing tens of millions of solar masses. No star phase, no gradual growth, just instant, catastrophic formation. These are called direct collapse black holes. The problem is that the conditions required for direct collapse are extraordinarily specific. You need pristine, metal-free gas. You need the absence of molecular hydrogen cooling. You need an intense background radiation field. The probability of all these conditions aligning simultaneously in the early universe is, by most estimates, vanishingly small. And yet, Virgil exists. Hypothesis 2. Primordial black holes. This is where the thought experiment enters territory that most institutions are deeply uncomfortable discussing publicly. Some researchers have proposed that certain black holes were not formed by astrophysical processes at all. They were baked into the very fabric of space-time during the first fraction of a second after the Big Bang, forged by intense density fluctuations in the primordial plasma, before matter as we understand it even existed. Recent high-resolution cosmological simulations have demonstrated that a primordial black hole, seated at 50 million solar masses, could reproduce the exact overmassive characteristics observed by JWST, including the extreme mass ratio and the unusually low metallicity of the surrounding gas. The math works. The models converge. But acknowledging primordial black holes as a formation mechanism carries a terrifying implication. It means the structure of the universe was not assembled gradually, galaxy by galaxy, star by star. It means the scaffolding was already in place, embedded, preloaded, before the first star ever ignited. Hypothesis 3. The population question. Consider the little red dots as a class. Over 300 identified, appearing suddenly, vanishing suddenly. No confirmed modern descendants, if even a fraction of them are Virgil-like. Compact galaxies concealing overmassive black holes behind walls of dust. Then we are not talking about an anomaly. We are talking about a pattern. A phase of the universe that we did not know existed, populated by objects that our instruments were never designed to see. The MIRI instrument on JWST is the only tool currently capable of piercing the disguise, and most surveys do not use MIRI at sufficient depth. According to the research team, the shallow observation strategy employed across the majority of high redshift surveys means we may be missing them entirely. An entire population of hidden engines, cloaked in dust, burning in the dark at the dawn of time. Independent analysts flagging this data have noted the unsettling symmetry. These objects appear to operate under a consistent set of parameters, similar sizes, similar dust profiles, similar energy outputs, as if following a template. The thought experiment asks, is that convergence natural, or is it architectural? This is the territory of the cosmic filter hypothesis, the idea that what we interpret as natural astrophysical processes may, at the most extreme scales, carry signatures of a structure that precedes biology, precedes chemistry, precedes starlight. Not intelligence in any human sense, but order, embedded order, encoded into the initial conditions of the universe itself. It is, of course, only a hypothesis, a thought experiment taken to its furthest boundary. But the data is real, the anomaly is verified, and the coevolution model, the single most trusted relationship between galaxies and their black holes, cannot explain what JWST found hiding behind the dust in the Hubble Extreme Deep Field. Virgil has two faces. One looks normal, safe, expected. The other, visible only in wavelengths our eyes cannot perceive and our older telescopes could not reach, reveals something that breaks the timeline. A universe where the engines came before the machines they were supposed to power. Where the architects, if they existed, left no signature except mass. Impossible, unexplainable, overmassive mass. 300 little red dots appeared in the infant universe. Then they vanished. Their descendants are somewhere. We have not found them. We have not even looked with the right instruments. The question is not whether the textbook is wrong. NASA already confirmed that it is. The question is, what replaces it? If you are still here, subscribe. The next feed may be the last one they leave open. 3I, Atlas.